This is brought to you by the Alumni Association of PISJ-ES.
Hey guys, today we'll be moving forward in our study in kinematics, and we'll be studying one more quantity that is very essential, which is known as acceleration. Yes, you have heard a lot about this, but it is a very misunderstood quantity. First of all, what is acceleration? Acceleration, the definition of acceleration is rate of change of velocity per unit time. So this means that a change in velocity per unit time. And I've always told you, whenever there is this word rate, this means there's always a time involved. Okay, so now first the understanding part. The understanding. Yes. Remember, whenever there is a change in velocity from one velocity to another, there will be an acceleration. For example, this car. This car is moving at a velocity initially 10 meters per second, and at time t is equals to 0 seconds. At time t is equals to 2 seconds, the car is moving at a velocity 2, which is 15 meters per second. So we can safely say that since there is a change in velocity in some time, the car has accelerated. Although it's moving in a straight line, there's a change in velocity per unit time, so there is some acceleration. Okay, let's first clear our concepts on acceleration, and then we'll come to the numerical part. Okay, example 2, for example. Here, I have a car again, and it has a velocity at point 1, which is 2 meters per second. T is equals to 0. A velocity 2 at t is equals to 2 seconds. Same car. Velocity 2, which is 1 meters per second. Now the velocity has decreased, but a decrease is again a change. There is a change in the velocity. It's not the same anymore. It's not 2 meters per second here. So per unit time, it has again accelerated, but negatively. Or you can say, since the car has decreased its speed from one point to the other, it has decelerated. Alright, so when there was an increase in speed from 2 meters per second to say 4 meters per second, we say it has accelerated. When the velocity decreases, the final velocity is lesser than the initial velocity, we say it has decelerated. Let's see now. Example number 3. This is the same car, and it has retarded wheels here. So at time t is equals to 0, the velocity 1 is 2 meters per second, and at time t is equals to 2 seconds, the velocity 2 is 2 meters per second. So since there is no change in velocity, although the time has changed, there is no change in velocity, the velocity is constant, and therefore zero acceleration or no acceleration at all. It did not accelerate. It was moving at a constant velocity. It kept moving at that velocity. It did not accelerate and reach a greater velocity. So this is the example. These are the three cases that we will be seeing for now. Now, talking about things a little numerically here, the formula for acceleration is something like this: v minus u over t. Now the v here, this means the final velocity of the object. This means the initial velocity, and obviously t means the time. Okay, so just understand this. For example, this is a car moving here. Again, there are so many cars moving. So at time t is equals to 1 second, for example, the velocity 1 is 5 meters per second. At time t is equals to 4 seconds, the velocity is 10 meters per second. Now the formula says if you want to find out the acceleration, we know it's accelerating since the velocity has increased. But if we want to find out the numerical value of the acceleration, what we will do is we will put the final value of velocity here, 10 minus 5, right here, velocity 1, the initial velocity, final velocity minus initial velocity. This gives me the change in velocity. Change in velocity. This sign shows change. This gives me a change in velocity, which is 5 meters per second. And the time t, for the time t, I can see that it started from 1 second and it ended at 4 seconds. So basically, the time elapsed has been is 3 seconds. Again, this is the change in time, which is 3 seconds. So you can see basically what we are doing is v minus u was simply change in velocity, and this t was simply the change in time. So we can now understand and write this formula instead, which means exactly the same thing. Change in velocity divided by change in time, where the triangle shows it's called delta and it means a change. So the velocity change was 5 meters per second and the change in time was 3 seconds. So the acceleration would be 1.667, and let's find out the units since it is something like this. So what happens, it's this case again, a over b divided by c over d, where 5 is the a, as in this m is the a, this s is here, and this c, this s is the position of c, and it doesn't have a dividend, for example. It's not getting divided by anything, so we'll just consider it to be 1. So we know by this rule this thing moves here and this thing moves here. We are figuring out the unit. So this becomes meters times 1 divided by seconds times seconds, which makes it meter per second square. So acceleration is always meter per second square, which means it has an acceleration, its velocity. What it means exactly, you have to understand this. This means that its velocity increased by 1.667 meters per second every second. This is 1.667 meters per second per second. So the velocity was increasing by 1.667 meters per second every second. This is what acceleration means. That every second there was an increase in velocity of 1.667 meters per second. So this is acceleration. that you should understand. So let me take another example here, and we'll be doing more complicated problems. So for now, just the easier one. A motorcyclist I'm doing an example here. A motorcyclist, this is a motorcycle. So this is the motorcycle, and this is the guy sitting here. A motorcyclist starts from rest. From rest means the initial velocity. Initial velocity is 0 meters per second. It's at rest. There's no velocity initially, and reaches a speed of 6 meters per second. So at some point it reaches a velocity of 6 meters per second, and after traveling, you know this is acceleration, but we do not know how much acceleration. So the question says that a motorcyclist starts from rest and reaches a speed of 6 meters per second after traveling with uniform acceleration for 3 seconds. So this guy traveled with a uniform acceleration for 3 seconds. The acceleration was constant throughout the journey. So now let's find out the acceleration. So first, let's find out the acceleration. So the formula for acceleration is final velocity, or v2, minus v1, which we call it as change in velocity, divided by delta time, which is delta t here. So in this case, we'll be considering the instantaneous velocities. Velocity at this point minus velocity at this point. This would give me 6 minus 0, divided by the time. The change in time between these two obstacles is 3 seconds. Always remember, it's a change in time. So this can be, for example, 56 seconds, and this can be 59 seconds. But the change in time is 3 seconds. This can be 81 and this can be 84. Change in time is 3 seconds. So the acceleration would be 2 meters per second square. The unit of acceleration is meters per second square. This means the car accelerated with 2 meters per second every second. It increased its speed with 2 meters per second every second. For example, at this point, at this original point, its velocity was 0. At time t is equals to 1 second, it increased its speed by 2 meters. So at this point, its speed, I am denoting it as VA, was 2 meters per second. At time t is equals to 2 seconds, its velocity increased by another 2 meters. So the next velocity was 2 plus 2, 4 meters per second. And at time t is equals to 3 seconds, its velocity again increased by 2 meters per second, which means 4 plus 2 gives us 6 meters per second. So the acceleration, the constant acceleration, and since this acceleration was uniform throughout the journey, so we call it as constant acceleration. So this is what acceleration means. So I'm pretty sure you would have understood the concept behind acceleration. Always remember, when a car is at rest, it's at 0 velocity and it's standing there for like 10 seconds. Obviously, in that case, acceleration is 0. The second case in which the acceleration is 0 is when a car has a constant velocity. For example, the car is we have seen this earlier, the car has a velocity 2 meters per second, and after 5 seconds, the same car has the same velocity. So since there is no change in velocity, the formula says delta V over delta T. Since there is no change in velocity, this is 0 over delta T, which means the acceleration is 0 meters per second square. So guys, this is acceleration. I hope you understood the concept. I will be putting in videos for more questions on both of these chapters, acceleration and velocity. So we'll be practicing more of the questions, and if you have any queries, just put them down in the comments box. Thank you for watching, guys.